Hi Class 5, welcome to today's lesson. It is maths and we're going to be looking at equivalent fractions. So think about what the word equivalent means. I'll just give you a second to have a think. If you want to hit pause, that's fine, but have a think what the word equivalent means. So the word equivalent just means it has the same value, it's the same, okay? If something is equal to something, it has the same value, okay? So we're going to be looking at equivalent fractions, fractions that are the same, fractions that have the same value, okay? Now, if we were at school, we might be able to look at the fraction wall that's on our maths working wall, but I don't have that in my home, and you might be a little bit like Mr. Salmon, and you might not have the things at home that you have at school. A little bit like me, so I can't get access to a printer. So what I've done, I've drawn my own to help us in this lesson of equivalent fractions. So come and have a closer look. Okay, year 5, so this is my fraction wall. Just for now, we're going to forget about these little black boxes down here. We're going to use those later. But if you look at this fraction wall, you might be able to see already that some fractions are equal to the other. So again, just a recap of equivalent fractions. Equivalent fractions are fractions that are equal to each other. They have the same value. Okay? So if we look at the top one here, this is just one whole. And if you notice, the numerator, which is the number on the top, is the same as the denominator, which is the number on the bottom. So if you have one bit of something that only has one bit, you have one whole. Okay, if you look at the half, it's one bit out of 2, which is the whole. Okay, so the numerator, 1, means I have one bit, which is here. The denominator, 2, means in total there are two parts of the whole. Okay, then thirds, again the numerator, this is 1 part, but the denominator, 3, there are 3 parts in the whole thing. And if you look throughout all of these, which Mr. Salmon has very carefully done, they are all the same size. So it always goes from this line to this line over here. So the whole part of them, the whole bit is the same. It's just the parts which are broken up here which are different, okay? Now, if you take a look like we did before, so the halves, there are 2 pieces, thirds, 3 pieces, quarters are 4 pieces. We've skipped the fifths, we're going to go to 6, so 1, 2, 3, 4, 5, 6. The eighths, 1, 2, 3, 4, 5, 6, 7, 8. Tenths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And lastly, the twelfths, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, you can break a whole up into as many pieces as you want. As many pieces as you want. You could do thousands, millions, you could do 100 millions if you wanted to, but realistically, today we're going to be working within these fractions. And if you look carefully, what Mr. Salmon has done is made sure the parts are the same size. So my halves are the same size, all of my thirds are the same size, my quarters are all the same size. So although I've done this fraction wall myself, I have done it very, very carefully, and each of the parts are of equal size. Okay, so back to that equivalent fractions. It's only a fraction if the bits, the parts, are equal. And we've just gone through all of those, so I'm happy with all of these fractions being equal, equivalent, equal parts of the whole. Okay, now, you might already know the fraction a half is equal to 2/4. Okay, now on this wall you can already see, well, the half stops on this line. If I go down to the quarters, yeah, that stops on that line as well. So 2/4 is equivalent to 1/2. Okay? Now, what I want you to do, this is where these black boxes come in handy. I want you to find out which fractions are equivalent to 1/2. Once you've got all of those, I want you to work out or see from the fraction wall which fractions are the same as 4/12. So I'll give you an example. The example again that we've just used, 1/2 is equivalent to 2/4. Okay, we'll go further down. It's not equivalent to any of the thirds because there isn't a line there. But if we go down to the sixths, yeah, 1, 2, 3. So that's equal to 3/6. Okay, now I'm going to stop there because I'm not going to give you all of the answers. I would like you to pause the video. You're going to write down the fractions that are the same or equivalent to 1/2 and also 4/12. Okay, so hit pause and I'm going to come back with you in a second and we're going to go over some of the answers and also an explanation of how we got there. Okay, good luck. Okay, so hopefully you had time to think and time to look at that fraction wall to see which fractions were equivalent and equal to 1/2. Okay, so I'm going to go through them now to see how many you got. So 1/2 was equal or equivalent to 2/4, but that wasn't the only one. There were a few more. It was also equal to 3/6. It was equal to 4/8. It was equal to 5/10. And the last one that it was equivalent or equal to was 6/12. Now, you might be looking at these thinking, but they're not the same. Because this has got a 4 in, this has got an 8 in, this has got a 12 in. But the word equivalent means that they have the same value. Okay, so a bit like if you were dealing with money. So 10 pence is equivalent to 2 5-pences. It's different. This is a 10 pence, these are 5 pences, but they have the same value. And it's just like these. They look different, but they're equivalent. They are equal. Okay, and these are equal for one reason, and it is because of this word multiples. Okay, so press pause and have a think, what does Mr. Salmon mean by multiples? Okay, so you've had to think about what the word multiples means. All it means is the times tables. Okay, so 2 times 6 equals 12. Okay, so that means 12 is a multiple of 2. It is also a multiple of 6. It just means if a number is a multiple of another number, it's in the same times table, and that's all it means. Okay, so I'll just get a different coloured pen so you can see this one. If we go from 1/2 here to 2/4, we must multiply something. The word, okay, multiples, it's multiplication, okay? Just like I was saying before, times tables, it's all about multiplying, okay? And that's where the word comes from. So, I must have to multiply that number and this number from the numerator to get to this numerator and the denominator to get to this denominator. I must multiply something, okay? So, have a think, what is the multiple that I need to multiply 2 by to get to 4? So, what do I times 2 by to get to 4. You can use your times tables if you're unsure, but just hit pause, have a think. Okay, so now you've had time to work that out, you can see that 2 times 2 equals 4. And coincidentally, you can see that 1 times 2 equals 2. That's why these are equivalent, because you've multiplied the denominator, which is the number on the bottom, by 2. You've also multiplied the numerator, which is the number on the top, by 2 as well. So as long as you multiply the top number, the numerator, and the denominator, the bottom number, by the same number, they are going to be equal or equivalent. Okay? So if we do this with another colour, so to get from 1 to 3, we times by 3. To get from 2 to 6, we also multiply by 3. We'll try it with this one. So if we get from 1 to 4, we multiply by 4. To get from 2 to 8, we also multiply by 4, okay? I'm not going to use a different coloured pen, it's getting a bit messy now, but I'll go through the other ones. To get from 1 to 5, I multiply by 5. To get from 2 to 10, I also multiply by 5. And the last one, to get from 1 to 6, I multiply by 6. To get from 2 to 12, I also multiply by 6. Okay? That is one way of showing why equivalent fractions are actually equivalent. Okay? Now, there's one more way, and we're going to go to that now. How you going, class 5? So, we're going to go back to the fraction that I had in the original, on the original board. Okay? And then we can look at how equivalent fractions are equivalent, but because of a different reason. Now, just go over the answers and see if you got both of them right. There were only 2 answers to this one. Let's see if you got them. So, 4/12, that was the same as, or equal, or equivalent to 2/6, and it was also equivalent to 1/3. So, well done if you got those, well done if you got 1. But we're going to go over why these are equivalent. Because again, you might be sitting there thinking, Mr. Salmon, this one's got a 6 in, this one's got a 3, they look different. But yes, they might look different, but it's what the value is. And the value of these 3 fractions are the same. A bit like what I said before about the 10 pence and the 2 5-pences. Okay? This is 10 pence, this is still 10 pence, it's just in a different way, but they are still equal, they're still equivalent. Okay? Now, these are equal because of another word that we're going to go over. You would have heard it. That word is factors. So have a pause, think about what do I mean by the word factors. So hit pause, have a think to yourself. Okay, so you've had to think about what factors are, and all factors means is what numbers you can multiply by to get this answer. So what are the factors of 4? Now, if you go through your times tables, you might know that, well, 4 is 4 times 1. It's also 2 times 2. Okay? Now, with the 12, what are factors of 12? Well, it is 1 times 12. It is 2 times 6. It is 3 times 4. It is 4 times 3. It's not 5 times anything. It is 6 times 2. Not 7, not 8, not 9, not 10, not 11. It is 12 times 1. And that's actually just reminded me that I forgot one of these. That is
4 times 1.
So that's what we mean by factors. Numbers that you multiply to get this answer. So 1 times 4 is 4, 2 times 2 is 4,
4 times 1 is 4.
1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12, 4 times 3 is 12, 6 times 2 is 12, and 12 times 1 is 12. So these are all the factors of 4, these are all the factors of 12. Okay? Now, we can use these factors to see what equivalent fractions are equivalent to this, okay? So if we pick, I will use the colour black, if we use a common factor, so a common factor means which one is the same in this and the same in this number, so which factors in the numerator are the same as the factors in the denominator, I can see that 1 is the same, but if I divide 4 by 1, I'm just going to get 4. If I divide 12 by 1, I'm just going to get 12. So we'll not use that one. I can see that 2, yeah, I can see that one. So if I divide by 2 on the numerator, and if I divide by 2 up here, those are equal to each other. So 4 divided by 2 equals 2, 12 divided by 2 equals 6. So we've used that common factor, the factors are the same, to help us with that problem. Okay? And again, in this one we can see the factors, so it's 1 times 2 and 2 times 1. So this is 6 times 1. It also 2 times 3, 3 times 2, 6 times 1. Okay? So if I use a common factor, which isn't 1, we can use 1, but it's just going to get the same answer, not an equivalent one that we want. It would be literally the same. Now, I can say again, 2 is a common factor. So if I divide by 2, and if I divide by 2 on this one, we get to the answers for the next fraction. So 2 divided by 2 is 1, 6 divided by 2 is 3. Okay, so we've used factors to work out which equivalent fractions are equivalent to this 4/12. Now, if I just forget about this middle one, we can do the same from 4/12 to 1/3. So give me a second, I'll just rub the middle one out and then we'll do factors for that one as well. Okay, so I've rubbed that out. I need to put the equals sign in because these are still equal. These are still equivalent. Okay? So to get from 4 to 1 and to get from 12 to 3, which common factor do I need to use? So hit pause, have a think of which common factor I need to use to get from this fraction to the equivalent fraction over here. Okay, so you've had time to think. You should be able to see that the common factor that we use is 4, and we can just check that. So to get from 4 to 1, we divide by 4. To get from 12 to 3, we also divide by 4. And just like before when we were working with the multiples, you had to do the same on the top with the numerators as the bottom with the denominators. This number had to be the same, and it has to be the same for when you use common factors as well. These numbers have to be the same, otherwise they won't be equivalent. Okay, so we've looked at why fractions are equivalent or equal to each other with multiples, and we've also used common factors. We know what those are now. Now I'm going to give you some questions and you are going to fill the gaps in or just answer the questions using our knowledge of multiples, using our knowledge of common factors to get the answers, okay? I will be putting the answers at the end of the video, so when you see the questions next, hit pause, and then once you've got all the answers, play the video again until the answers come on at the end, okay? Good luck everyone. Okay, so you've had a go at the questions. I'm going to go over them now. Now it said use your multiples. I could just use an easy one, 3. So 2 times 3 is 6. 5 times 3 is 15. That was an example. Let's go a little bit more adventurous. I could do 12. So 2 times 12 is 24. 5 times 12 is 60. Now, you might not have got these exact answers, but you can check if yours were correct just by seeing if the numerator was times by the same number as the denominator. So here I times by 3, here I times by 3. In your answers, as long as these numbers are the same and they work, then that is a correct answer. Next, I can use my factors. So that was using common factors of the numerator and the denominator to get to an equivalent fraction by dividing. So a common factor of 4 and 36, well, 2 goes into 4 2 times, and 2 goes into 36 18 times. So what I've done there, I've divided by 2. Here, I've divided by 2 as well. I can go one further than that. I can divide by 2 again. So 2 divided by 2 equals 1. 18 divided by 2 equals 9. So well done if you got those. Now, the last one, is 4/20ths equivalent to 48 220ths? Okay, explain your answer. Now that's a little bit of a mouthful, but it's still got the ths on at the end, okay? The answer is no, and I'm going to show you why. Okay, so I've got these two fractions here. Think about what I times 4 by to get to 48. Well, I know 4 times 10 is 40, 4 times 2 is 8, so the 10 and the 2, that is, I'm timesing or multiplying by 12. Now, this is a bit of a bigger number, but we can use our multiplication still to get from 200 to 220. I know that, sorry, to get from 20 to 220, I beg your pardon. Now, 20 times 10 is 200, and I've got 20 left, so this I'm only timesing by 11. Okay, so on the top for the numerator I've times by 12, on the bottom for the denominators I've times by 11. So because these numbers are different, these are not equivalent fractions. Just as an extra bonus, what would this number need to be for these to be equivalent, for these two fractions to be equivalent? Hit pause, have a go, and you'll see the answer after. Okay, so if I times or multiply the 20 by the 12, because it has to be the same for the numerators as the denominators. 20 times 12, well I know 20 times 10 is 200. 20 times 2 is 40, so this would have to be 240. This would have to be 240. So 4/20ths is equivalent to 48 240ths. But the original answer was no. Okay, well done today, and I will see you for the next lesson. Bye.